Hello everyone, welcome to Microsoft Build. I'm Lucas Polidoro and a Principal Program Manager responsible for the identity APIs. Today I'm going to show you the advanced queries in Microsoft Graph, a feature that we released a couple of years ago, and today we're going to see all the advancement that we did in this last period. Here's the agenda, a very quick introduction on the feature, the internal architecture to explain some of the deep dives, and the main part will be the query samples. And the end, of course, a recap. All right, let's start with the familiar Microsoft Entra portal, formerly known as Active Directory portal. And here you can see that you can search, you can count, you can filter, and sort the data in your tenant. And these are the basic features that you really expect from any service dealing with data. But if you remember, just 3 years ago, these functionalities were not present. And today, 2 years ago, we exposed these via APIs. But if you're familiar with Microsoft Graph and you have experience working with the identity APIs, you may have faced all these errors. Now let's take a look why this is happening and the internal architecture. So we have Microsoft Graph that we all know and love, and when it receives a request from an identity workload, it would redirect the call to something that we internally call REST RDS. This will ultimately execute the read and write that you request to our internal directory store. Now, let's see how advanced query works. As the fundamental theorem of software engineering says, all the problems in computer science can be solved with another layer on the indirection. This is exactly what we did. We have advanced query service that is going to handle all these advanced queries, and is getting the data from another store, an index store that is advanced to do range queries and graph queries. These two stores are synchronized by a sync engine. So every time a change happens in the directory, that exact change is replicated into the index store. All right, and then you can ask why then we are not using all the advanced queries, just the advanced query service instead of REST directory service. And this is because advanced query service only support a reduced number of directory objects. So for all the rest of the directory service, the directory objects that are not supported, you will use the normal REST directory service. Now, let's see a demo on how to use advanced queries. All right, here we have Graph Explorer. And to start, let's get the list of users. So here you can see that we have the response. And in this case, we are using REST directory service. But if we add two special parameters, one is a query parameter called count, $count equal true, and we add a special header, consistency level equal eventual, you'll see that now the query contains this special OData annotation, this count. And in this case, we are using advanced query service instead of REST directory service. But why we need these magic parameters? Well, let's get back to our architecture. When a user really executes a request to Microsoft Graph asking for a directory object, Microsoft Graph doesn't know which service to redirect because both REST directory service and advanced query service are able to answer. So when the request contains, for example, count or search or something that only advanced query service is able to respond, then there are internal rules in Microsoft Graph that allow this to redirect to the right service. But let's see what happens when we do a write. This change will get sent to the directory store, and the REST directory service immediately acknowledges the writes. But at the same time, REST directory store is a highly distributed store with replicas across the globe. And you can imagine that replicating this change across all the various servers will take some time. The sync engine is actually listening to some of the replicas, not listening to all of them. So only until the replica that sync engine is listening to get the change, then the sync engine will process the change and send it to the index store. And now you can see that the directory store and the index store are really not in sync, meaning that they are not able to have the same change at the same time. And that's why we require also the consistency level eventual header to indicate the choice for you, the developer, that the query that you are getting a response from is eventually consistent. And by the way, we are also trying to reduce the latency that is currently around 1 minute, 1 minute and a half by doing this. So every time there is a write to directory service, the index store is also immediately updated via another service. So this is coming, is not yet in production, and stay tuned for seeing improved latencies. All right, now we are going to see all the HTTP and C# code samples. That is the main topic of this talk. I'm going to do a few assumptions for brevity in my slides, otherwise they will be too crowded. So first, all the REST HTTP requests will be GET, because even the advanced query service is a read-only service. And every request automatically would include the consistency level eventual header. On the counterpart, on C# SDK, the eventual consistency header is declared as you can see there. And all the calls are including this eventual consistency header. And also I'm stripping out the graph client part, so you will only see from the user part onwards. All right, so sample queries count. Count allows you, as I showed before, to count the number of users or groups or application, basically any directory objects in a tenant. And to answer the question on how many users are in the tenant, you just do /object name /count, and you get what we call a row count. That is just a long that you can parse in your code without any JSON wrapper around. While instead, if you want to get the count and the list of users, like I showed in the example before, you can use the $count equal true query parameter. So you see the difference? Before, I'm using a query segment, and now I'm using a query parameter. And also, I added a filter because the count that you will get also respects the filtering that you added. Next is my favorite parameter, search. So search use tokenization to find the right directory object that you are looking for. And tokenization works by breaking down a string into smaller parts called tokens with some rules that you see in the table above. Let's say an example. If I want to search for admin with the display name, the match of the word admin would find everything that has the word admin lowercase, the word admin uppercase, but also administrator, because it starts with admin, and test admin, because this word, test admin, is split into token thanks to the different casing category. So these two, if the input string is, for example, hello world, the token will be 2 separate tokens. The second part is a bit weird, but what we do is, if we find a space in the word, we also collapse the word together and we match with the input token. So add space min would also match admin. And the last example is of O365 admin, where we split through numbers. And negative match is admon, because this is a completely different word. And super admin. In this case, there is no separation between lowercase, uppercase, or special characters. So for the engine, this is all one token. The mail part, in here we have an OR clause, is matched only with the starts with, because only display name and descriptions are supported for tokenization today. So the positive matches will be everything that starts with admin, of course, but if we have a 1 before the word admin, would not match. Order by. So sorting is supported with a handful of properties and is supported with advanced query in conjunction with filter. So if you try to filter and sort with the normal REST directory service query, you will get an error. So this is required. So the count equal true that you see here and the consistency level parameter are required, even if you don't need the count, because Microsoft Graph needs to know that this query has to be redirected to advanced query. And to sort and count, to filter and order, you do like this. And this will return you the users in built-in 18 sorted. Okay, so you see here the count equal true is absolutely necessary. To filter collection instead, we have two cases. One, if you want to get, for example, the user in a tenant where the proxy address, that is a collection of mail, basically, ends with Microsoft.com. In this case, you see that we use the keyword any, the operator any, and we also have a support for not. Not and any are supported with advanced queries. So if you need that in your query, remember to add the parameters. And also we support filtering on the count of a collection. And the filter on the count for now is you can select only equal 0 or equal 1 because we believe that it will cover the most scenarios. And of course, you can also do not equal 0 to filter the non-empty collections. Transitivity. All right, so as you know, group members can be of various types. You can have users, you can have application, service principal, and even other groups to, for example, create nesting. This API allows you to unroll the nested list of groups into a flat list by choosing a specific type. This is called ODataCast, and is supported both, of course, in the HTTP REST endpoint and in the C# SDK. Next, we have a way to build applications that are dealing with the organizational chart. And our Org Explorer is effectively built on this API. So here I'm going to show you the transitive managers count and transitive reports, how they are built into this application. So to count the number of reports, you can use this API, and this API is only supported for count because unrolling, for example, every employee under Satya will be very expensive, and this other API instead is to get the manager chain all the way up to the CEO. And it's very different from the one before because in this case we are using expand, and we have these other parameters, $level equal max, that will tell the expand clause to expand all the way up to the root level. So this is the case where the levels equal max is one of the discriminators that I was showing you in one of the earlier slides. And this doesn't require count. Also because count on the individual user really doesn't make sense. So you can use this API just by using expand, levels equal max, and the eventual consistency header. Now we are going to show you some of the APIs that allow you to get all the service principal assigned to a user transitively. This sounds a complicated API, but in reality, it's very simple. We built this specifically for my apps, and this is also very efficient. It will return every service principal unrolling all the transitive groups. The opposite, so another API that is related to roles instead of app role works like this. So we have a role management part in the Graph APIs and a transitive role assignment API that requires, again, count and eventual consistency header to work. In this case, we are filtering the principal ID equal to user ID to get all the roles assigned to that user ID. Batching. Batching is very important because it can save round-trip latencies, and is a good optimization if you need to send a bunch of queries at once. The trick to use batch with advanced query is to add the eventual consistency header in the request body. So you don't have to add it into the HTTP post request because it doesn't really make sense, but you need to add it to each of the individual requests in the body. Now, we have few unsupported parameters and tenants that we are going to address in the future, one of which is expand, except the transitive manager that I showed you before. The generic expand will silently fail, so if you try to add an expand clause, the query would not fail, but you will not see the expanded property. And skip is also not currently supported, but of course we'll support skip token. So if you have a pagination kind of UX, you might need to use skip token and cycle over all the pages in this case. And for the last, all these advanced query capabilities that I showed you before are not supported in B2C tenants, the business to consumer tenants. And while it might be disappointing, we will announce here at Build that there is a new kind of tenants designed for external identities that will fully support advanced query. So that's a good news. And lastly, a recap. So first of all, only directory objects and identity APIs are supported. And you need to be aware of eventual consistency. This means that if your app is only reading directory data, then you really don't have no issue. If you're a read-only app, you don't have to deal with eventual consistency. But if your app writes and then requires some user interaction to read, then you can use some local caching or crafting some appropriate messages, like asking the user to refresh the data if the new change is not there. The third case is the most problematic, is when your app, for example, writes and immediately after reads. For example, by using automation or in test environments and some sort of scenarios. In this case, our recommended solution is to use an exponential backoff strategies, where, for example, if you created a user and then you want to query the list of users, making sure that the user is already there, you can implement these queries that are sent on an exponential backoff timing. So once you get the new user that was created, then you can stop and show the list to your application and use the list in your application. Again, search is tokenized on a display name and description, and all the other properties would default to start with. We are also looking to add new properties and supporting tokenization, and we'll have something to announce shortly. Filter on under by only works on a subset of properties, and this is the Microsoft Graph docs page that you can go to show to see everything that is supported currently. So also filter and order by are only supported together in the same request and are only supported with advanced queries. We also support not and e and not equal, and these are not supported in the normal RDS REST directory service, and that's it. So in this page, you will see all the documentation and sample that you need to get started on advanced queries. And that's it. I hope you enjoyed the presentation and you learned something new. As usual, send the feedback through the Microsoft channel. We are always listening.